Yet we are live on the internet. Okay.
What is happening?
Huh? You all right? Okay. We're live on the internet.
So,
Yes.
okay.
Yeah. What is a fraction? Anybody want to help me out?
Not a whole number.
Not a whole number. Excellent answer. Anybody else? What is a fraction?
Part of something?
Anybody besides Bailey?
Okay.
I'm just kidding.
Oh.
Is it a part of something? You said a part of something?
Something.
Something? Okay. Anyone else? This time besides Bailey.
Instead of piece of a whole.
A piece of a whole? Okay.
It's like a fraction.
Okay. Whole. Okay. Can you draw me a picture of a fraction?
Pizza slice.
A pizza slice.
That's what I remember most about learning fractions in elementary school is pizza. Like we had it.
What part of a whole is that? I don't have enough information there, right? Okay, so wrong. What? Okay, so something, so we're just going to get a little more specific about what a fraction is. So usually when we're talking about fractions, we talk about equal parts of a whole. So that's an important word there. So if I want to use the whole pizza thing, I draw my pretty little circle pizza, and then I attempt to split it into pieces. I find thirds very hard to draw, or fifths, you know what I mean? To make them look equal. I'll show you a better way to do it in a minute. So I'm going to go for quarters. They're easy to do. So I'm making believe they're all the same size. So to the best of my artistic ability, that's a picture of 1/4 of the pizza, right? Now, there's slight distinctions about the different ways to look at fractions. This is equal part of a whole area. And I think it's a slightly different but related idea to talk about equal parts of a whole group. One of these does not look like the other. I'm not going to make any gender commentary here, but I'm going to say 1/4 of these is different. It's got a triangle body instead of a line body. And the fourths could be cut up differently up here, but I'm not going to go cut people up different, right? So that's like a fundamentally different idea, even though they're both parts of a whole. We can have part of a whole area, we can have part of a whole group. And part of a whole group is pretty much counting, but part of an area can be a little bit different. Like, suppose this was my sketch of the pizza. Suppose I cut it that way. Each of us gets one of these 4 pieces. I get this one. That's mine. Okay, is that fair? Right? And, okay, so I think part of a whole area is slightly different than part of a whole group. They're both representations of what a fraction means. Sarah?
How does like baking work with this? Because you get like 1/4 cup. This is that part of the whole area or part of something else?
So that's I would say that's more like an area because we have a volume of stuff that can be split up in a lot of different ways.
Would that be the same like a ruler then? Because it's all marked up. 1/2 inch, 1/4 inch.
A ruler would probably be closer to an area also. Good call. So a number line is kind of similar there too. So those are 2 common ways to look at a fraction. Agreed? And sometimes we're talking about part of a group. Sometimes we're talking about part of a whole object that has to be sliced up. Right? But there's different ways to look at it. So I'm just going to pick on a different fraction just to make it a little more exciting. I'm going to show you a couple other ways to look at 2/3. That's a picture of 2/3. I have 2 blueberries and 3 cherries. Okay. Is this a part of a whole? Answer is no. Altogether, there's 5 pieces of fruit up there. So 2/5 of them are blueberries. But there are 2 blueberries, right? And there are 3 cherries. This kind of fraction here we usually call a ratio. I'm looking at the ratio of blueberries to strawberries.
That's not really a fraction though, right?
It is totally a fraction.
The picture?
Yes. Yep. Yeah, so I'm looking at the ratio of blueberries to cherries, let's say. And in this situation, I have a ratio of 2 to 3. For every 2 blueberries, there's 3 cherries. So I'm making a pie. That pie has to have 2 blueberries for every 3 cherries. Otherwise, it's not going to taste the way I want it to taste. Okay? So, well, a ratio leads to a proportion. A proportion is where you say, okay, I need like 800 strawberries. How many blueberries would I need? So that's more complicated. We'll get to that at the end of this section. But bottom line is, just as far as what does a basic fraction mean, it's not always a part of a whole. Like a lot of times we talk about the ratio of males to females in a given group. Okay? So often it's like 50-50. Right? So for every 50 males, there's supposed to be about every 50 females. Now, that's like in the general population. It doesn't work in every small group, but sometimes a fraction is a ratio. That ratio is not part of the whole. And we use these things all the time. Anybody drive their car? You ever look at the speedometer? What does the speedometer measure things in? Miles divided by hours. It's a ratio, right? And it's a fraction. Per means divide. Okay, so that's another way to look at it. Another way to look at it. Let's take 2/3 again. So I have 2 candy bars. And they're exactly the same size to the best of my ability, I believe. But I had 3 people to share them with. So I'm going to slice them maybe about there and about there. So this is where Gary gets. Oops, there's an extra line. I'm freaked out. This is Gary's share, if I cut it right. This is Ruby's share, and that's Julia's share over there. And what I was imagining is an imaginary line right there and right there. So what did I split each candy bar into? Thirds. And how much did each person get? 2 of those thirds. But here, this is actually a division problem. Okay. There aren't 3 candy bars. There's 2 candy bars, and I had to split them up amongst 3 people. Okay. So each person is getting 2/3 of a single candy bar, and that's a little different than a part of a whole. Okay. So that's a slightly different way of looking at it. So we've got part of a whole group, part of a whole area. We have a ratio. We have a division problem. See anything? One other idea about how we view fractions in reality. Yeah, I guess that one's different too. All right. And a 5th way of looking at fractions is position. That position I've arrowed over to right there is 2/3 of the way between 0 and 1. So that's a slightly different way of looking at a fraction too. So I have 5 different ways to visualize what it means in a fraction, and they all have practical applications. Okay. So bottom line is when we're analyzing these things, we need some kind of physical situation that embodies what the thing we're talking about is. Most of the time when we're doing our work, trying to teach how to add, subtract, multiply, and divide, working with the part of a whole is going to be the easiest approach to start with. But there's tons of other places fractions come up in our lives that they're not part of a whole. Right? All right, so that's thing number one. Next thing we have to do is kind of get used to them a little bit more. So the title of this chapter is actually called Rational Numbers. And rational has the root of ratio. Ratio is one of my versions of what a fraction means. And a ratio is just the quotient of two whole numbers. Any two whole numbers? Almost. So usually we say a rational number is some whole number A divided by some other whole number B. Often we write it stacked like that, but it could be written with the slash, right? That means the same thing. And it could be written with that symbol too, that division symbol. Typically, when we're talking about fractions, we're either going to use this version or that version to talk about the fractions. The catch is this only works if the bottom, the denominator, is not 0. Right? We talked about that last term. We can't divide by 0. It leads to problems. The numerator can be 0. The denominator can't. So a rational number is just the quotient of two whole numbers. Now, with that in mind, so a fraction is a rational number. It turns out that whole numbers actually are also fractions. Because a rational number is the quotient of any two whole numbers as long as the bottom is not 0. So for example, 4, we think of as a whole number, is also a rational number because you could view it as 4 over 1. Okay. Now, we'll get to this in a minute. I could also view it as 8 over 2. So there's usually a unique way of looking at a whole number. There's a lot of different ways to look at the same value for a fraction. 4 over 2 is the same, 4 over 1 is the same number as 8 over 2 when you clean it up. Because 2 goes into 8 how many times? 4 times, right? So that's the same number, just written a little bit different. So whole numbers turns out they are fractions. Now, we usually like to call fractions part of a whole, but isn't the part supposed to be smaller? Yeah, so that's a problem here. So when we think about the idea of part of a whole, the idea we're really talking about there are proper fractions. This 8 over 2 or 4 over 1 falls into a category, what would I call that? It's not proper, it's an improper fraction. Okay, so other important things. That number on the numerator, the number on top is called the numerator, the number on the bottom is the denominator. What does numerator mean besides the number on the top? What's the root of that word? Numerate. What does numerate mean? It means two number, which means two counts. It means count, how many? Numerator just means how many. Denominator.
That would be
Denominate, denomination. What does that mean? Ever heard that word used in other places? Money. Yeah. Is it a 1, a 5, a 10? That's denomination. Religion. Are you Catholic or Protestant? Right? It's a description of something. So the denominator is just a description. And the top says how many of that thing we have. Okay. All right, so next we're just going to play around with mostly proper fractions, but a little bit of improper fractions. And we're going to use toys to do it. So that's the basics of what is a fraction. We'll use those ideas to figure out how to add, subtract, multiply, and divide. Possibly get to addition today, but maybe not. New page. And toys. So the two toys we're going to play with is we have pattern blocks to play with. I'm just going to use these 4 pattern blocks. I'm going to ignore the square and this other skinny rhombus. And then we played with the color rods the other day, so we're going to use the color rods again. And the key on this is anytime you use toys to talk about fractions, you always got to put a key somewhere that says this is what a whole looks like. Once we know what a whole looks like, we can talk about what the fractions of that whole are. All right, to play with these, we are going to whip out a couple of activities. And let's see here. Is the old book numbered the same way as the new book? The old book, number 1 was what is a fraction, and I think the new book, that's true too. Let's see, new book, chapter 6.
What is a fraction?
Yep, cool, okay, so that matches, and then
What page?
that,
93.
93, yeah, thanks. And so we're going to do that. I'm going to skip over square fractions. If we have time, maybe we'll come back to it next week, but I'm not sure we're going to have time. It's a fun one, but it takes a while to do.
So we're not doing activity. Oh, this is all.
Okay, so that's the old book. Okay. So in your activity, it's called activity 3, equivalent fractions. That's the next one we're going to do. So we're going to play with both of these today. Okay. So activity 1, activity 3, let's get started in activity 1. Yes, I do. This is chapter 6, activity 1. All right, so for the studio audience out there, here are my fraction pattern blocks. Yes?
Really sorry. Are we going to do activity 4?
We are pretty sure not. No. The next activities we're going to do are 7, 8, and 9.
Okay, so I can do that. So we're doing activity
1, 3, 7, 8, and 9 is what we're going to do. So I'm just going to get you started on this one, and then we'll take a quick look at the next one. And then I'm going to stop this video and start a new one. So when we talk about part over a whole, we're doing a comparison. And one way to compare is to have some things to hold on to. I think that's a great way to start. So the trapezoid is what fractional part of the hexagon? So reminder, trapezoid is this red shape right here. A trapezoid has 4 sides, a pair of which is parallel. If you set it on top, you'll see 2 fit on there quite nicely. And so, yeah, we can answer a half on that one. And so the nice thing about the pattern blocks is we can pick one up and stick it on there, and we can see, it looks like a second one will fit underneath. And we can grab a second one, and see, I think I can rotate these somehow. I swear I used to be able to rotate these. Oh, come on, play nice. Oh, there it goes. I just grabbed the right corner. So I can see 2 fit there, so it's 1/2. Let's see, the rhombus is what fraction of the hexagon? So we stick the rhombus on there, we'll see 1 fits there, and a second one fits there, and a third one fits there. So that would be a third. The triangle is what part of the hexagon?
1/5. 1/6.
Yeah, it turns out 6 of them fit quite nicely if you play around and throw them on there. What if we compared the triangle to the blue rhombus? That would be 1/2. And how about the triangle to the trapezoid?
Which one's the trapezoid?
Trapezoid is the red one.
Oh, okay.
1/3, yeah. So I'm just gonna put this there, and then I can see 3 triangles fit nicely on that trapezoid there. Now, there's gonna be some parts of these where I need you to draw me your opinion of it because I can't see you play with the toys necessarily. So I'm gonna hand this out in a minute, but on the website, I have a page called Miscellaneous Resources. On there, I have links to the online versions of these I'm playing with, like pattern blocks and color rods. I'm also going to hand out what's called isometric dot paper. So, that 2 and black, PDF it. You there, sure. So isometric dot paper looks like this. So if I zoom in on this a little, you can see that you could trace around and easily draw a hexagon, or you could draw the rhombus on there. So if everybody could grab a couple of sheets, you might need one of them today. I have enough for at least 2 for each of you. You're certainly going to need them on the later activities, like 7, 8, and 9 when we get to them. So the next part's pretty straightforward. We're going to get some more exciting play with the Cuisenaire rods are also called color rods on the second page here. And we switch which one gets to be a whole, which is going to be challenging for our brains. Yes, what's up?
The second part, the what fractional part of each figure is shaded, unshaded, do you want the actual fraction, the smallest?
Reduced, simplest form? Yeah, so for now, I don't care about reduced.
Okay.
We'll get into that in activity 3.
Okay.
Yeah, so for now, it doesn't have to be reduced. Okay, so I'm gonna pause this video here and we'll come back with a new video and some answers because this is gonna get boring for you online folks.